Welcome to the new beginning. So far we have covered the two major topics which were AP and GP. In this part we are going to see what happens when the two comes together. Till now we have seen that a term may be in either a term of AP or a GP. In this part we are going to see that a term will comprise of both the terms, one in AP and next one in GP. So this lecture will be completing the whole arithmetic geometric progression. Let's start this chapter. So coming to the first part, we will talk about arithmetic geometric progression, the appearance, how does AGP looks like. Okay, so till now we have discussed about arithmetic as well as geometric separately, but here we are going to study about both together, what happens when we mix up the two things. Okay, so clearly as written here that suppose these terms are in AP and these terms are in GP, so how would the AGP look like? So it will be something the product of corresponding terms. Okay, so here is an example that how it looks like. So this is the general appearance and this is one specific example. So as you can see, the first term, which is 1 into a here, 2 into a square, so this is going on AP and this is going on GP. So basically we have mixed up two things and we will apply the properties of both to solve such sequences. Let us have a look at the important thing from which the question often comes in the JEE Advanced as well as Mains. So how to find the sum of n terms? So like we did for the GP and AP, we will write first the general expression. So if I start from the A, and this will be my AP, and what I am doing is I am taking the first term of GP as 1 and then the common ratio R. So this is how it goes, and we will write the last two terms, or in this case this is the last term basically, and ratio will be Rn minus 1. So again if I write it like this, so like we did in the GP, so clearly we can observe here that if I multiply this, and why I am multiplying this you will just get in a minute, that I am just shifting one term ahead and plus I am multiplying it by R. So this will give me, so here the second last term will appear, which will look like and the last term will be now. Let us see why we have done this. Okay, so now if I subtract, what will I get? So clearly I'll get here Sn 1 minus R. Okay, so this will be A. Now if you subtract it, so what are we getting? AR will get cancelled, only DR will be there. Here again if you see, you will have A plus D. I can break this as A plus D plus D. So this term will get cancelled with this when we subtract it, only dr square will be there. For nth term, let us have a look. So clearly I can write it as n minus 2 d plus d. So again I am getting d r to the power n minus 1. So clearly this middle terms and last term will be as it is such. So clearly this is forming a GP now. If I take common d, or even that is not necessary, if I take d out, so it in fact dr out, so it will be 1 plus r and this will be r n minus 2. So these are clearly n minus 2 terms, or if you look carefully, this is not n minus 2 because we are starting from r raised to power 0. So this will be n minus 1 term, because from here to here it will be n minus 2 and 1 term also. So last term it will be written as it is, so I can write it as L, and when you will do this, so if you remember, this will be first term is 1, so that is not a that won't matter. So 1 minus r raised to power n minus 1 upon 1 minus r plus last term. So this is how we get so the sum of n terms, although the derivation of it is not important as such as we did in the case of AP and GP, but when we will do the question, it will be quite evident and quite clear that what is the methodology. So application of this is very necessary, how to do that, because this is just the structure that how do we solve. So we have to remember this step. This we will apply when we will do the question. So just divide, when we will divide it 1 by r, okay, again there is concept which involves sum of infinite terms. So again, like we did in the GP case, similarly we will write this as 0 because this will become, as r is less between -1 to 1, so anything raised to power infinity will become 0. So this will just reduce to dr over 1 minus r, and again some simplification will be in this term also, because this is again r raised to power n. Okay, so final term for s infinity, that is again that you can remember, that is easy formula. So this will be a upon 1 minus r plus dr over 1 minus r whole square. So this term is clearly evident that 1 minus r, when you will multiply in the denominator, this you will get, and this term we will get when we will simplify this and this. So let us have a look at the question, and this concept will become more clear. Okay, so let us first write the series and see what kind of AGP it is. Okay, so clearly if I see, these terms are going in AP with the difference 2. So till now, if you have practiced about how to find the nth term, so clearly for this 2n plus 1 will be the nth term for this, and for this, if you look at this, so if you take common 5, so, or we can start with a as 5 and the ratio as 3. Okay, so I'm writing first Sn as 3 plus 5 plus 5 into, I can write this as 5 into 3 plus 7, 5 into 3 square plus, yeah, so this way it will go to nth term, and we have find the nth term just now, so it will be 2n plus 1, and upon 5 is obviously there, that is not of a matter, 3 raised to power 0, it means 1 minus 1, so it will be 3 raised to power n minus 1. So now again we will follow the same step. What is the ratio? 1 by 3. So we'll multiply it by 1 by 3, and this will give us, we'll shift the term here, so 5, this will be upon, it will be 3 here, so 3 over 5 into 3, so we have made basically the denominator same, plus 5 into 3 square plus 7 upon 5 into 3 cube, and the last term will be, when you will put n minus 1 here, it will be 2n minus 1 over 5 into 3 raised to power n minus 1, and last term will be as such, so it will become plus 2n plus 1 over 5 into, carefully remember students, lot of them make mistake while adjusting the powers. First they write correctly, but at the end sometimes the mistakes. So when I now subtract this, same step I'll follow, so we'll get 2 by 3 s or Sn we can write, and this will be equal to 3 by 5 plus, so again if you subtract these two, you will get 2 here, so 2 upon 5 into 3, this is again plus 2 upon 5 into 3 square. So it's now clearly evident that this will again become 2 over 5 into 3 raised to power n minus 1, and the last term will be as it is, minus, remember the sign, this is again a step where student lot of time makes a mistake, and option is given as such, considering this sign to be positive. So this will be 2n plus 1 over 5 raised to power 5 into 3 raised to power n. So now this is clearly we can solve as a GP. Take 2 common out, 5 common out. So I am solving the continued part here. So this is starting from, let us say here. So 3 by 5 will be as such, and if I take 2 by 5 common, okay, so it will be a GP with first term as 1 by 3. So I'll take 1 by 3, ratio is 1 by 3, and it will be not like this, it will be 1 minus 1 by 3 raised to power, remember how many terms these are always, so this starting from 1 to n minus 1, so hence n minus 1 terms, upon 1 minus 1 by 3 is 2 by 3, and the last term will be as it is, no need to touch that till the last step. Okay, so now this we can simplify, and finally after simplifying we'll get 2 by 5 into 2 minus n plus 2 over 3 raised to power n. Okay, so this simplification you can do, that simple, when you will solve all these and plus this term, finally we will get something like this. And when it is talking about s infinity, okay, so clearly from this, and it will be not 2 by 5 here, as 3 is there, okay, so 3 by 5 will come here finally after doing the calculations. And s infinity, if you look, you just have to put n as infinity, okay, or you could have done that in the earlier part also, but once we derive s in general we can do that. So clearly 3 raised to power n will be greater than this n and have a larger effect, so this term will become 0 and this will be 6 by 5. So that was about the AGP, and the important step was learning this. So you need to practice more about this, so that the speed is a major issue while solving these questions. Concept as such is very easy to understand once you are familiar with arithmetic progression and geometric, but main thing is solving time. So we have to solve quickly, think orally, and perform these calculations very quickly. So we have seen that how the terms play when both the AP and GP comes together. It was looking difficult in the beginning, but once we see the questions we will see that it's not that tough. And one major thing, this part and the next part which we are going to discuss in the next part, so stay tuned for the next part.